Here in this question, we're asked to use algebra to prove that the square of any natural number is either a multiple of 3 or is one more than a multiple of 3. So we know that we're going to be dealing with the value 3. So we know that any natural number can be written in the form of something to do with 3k. So for example, we'll have that any natural number can be written like this, so 3k. And then it can also be written as 3k plus 1 because we can add 1 to it. And then it can also be written as 3k plus 2. And then essentially we could write it as 3k plus 3, but that's just going to bring us back round to the same value as 3k. So we'll just write that in here. We can express natural numbers in this form. And to prove what we want to prove here, we're going to work with 3k, 3k plus 1, and 3k plus 2 to show that we're going to have the square of that is either a multiple of 3 or one more than a multiple of 3. Okay, so to begin with, we'll work on the 3k case. So initially, what we'll have is we'll have 3k all squared, and that is going to be equal to, well, 3 squared is 9, and then k squared, so we'll have 9k squared. And bear in mind, we want to see if this is a multiple of 3 or one more than a multiple of 3. So we need to think, is there any other way we can write 9k squared? Well, we can, because 9 is equal to 3 times 3. So this is going to be written as 3 times 3 lots of k squared. And what's this? Well, this is a multiple of 3. So that's the first case completed. So we're going to look at the second case. So we'll have 3k plus 1. Just underline that there. So we'll square it again, 3k plus 1, and we'll square it. So what's that going to be equal to? Well, we'll just write out our working here. So 3k plus 1 multiplied by 3k plus 1. So our first term will be, well, 3k times 3k, which is 9k squared. And then we'll have 3k plus 3k, which is equal to 6k. And then our constant on the end will be 1. So we need to have a think, what can we do here? How can we rewrite this? So what do we see? We see that these two values here are multiples of 3, and then we have a constant 1 on the end. So we'll take out our common factor of 3 from these highlighted terms. So we'll have 3 lots of 3k squared plus 2k, and then we're going to add on our constant 1 to that. So what do we have here? We have a multiple of 3, and we add 1 on, which is again part of the criteria we're looking for. So we can see that this is, so we'll just write that in. So we have 3 lots of 3k squared plus 2k. And what's that? Well, that is going to be 1 more than a multiple of 3, which again ticks the boxes that we're looking for here. And then what we want to do is we want to take a look at this final case here. So that's going to be the 3k plus 2 case. So once again, we're going to square this. So I'll just write this in here, 3k plus 2, and we square it. So just writing our working out, we'll just copy it out here. And then we have, this time we're going to have 3 times 3 again, which is 9. And then we're going to have k squared. And then this time it's going to be 3k times 2 plus 3k times 2, which is 12k. And then finally our constant is this time going to be 4 as opposed to 1. So just like this. So we need to have a think, what can we do to simplify this? So we want to look for a multiple of 3, so we'll take a common factor of 3 out. So here we'll have 3, and we're going to multiply it, and it's going to be 3 multiplied by 3k squared, because that gives us 9k squared. And then how do we get to 12k? Well, what we'll have is we'll add on 4 lots of k, since 3 times 4 is 12, and then we need to have a think. So we're looking to make it 1 more than a multiple of 3, and we know that if we put a 1 in our factorization here, we can then add 1 on to the end, and we'll have our terms here, and then we'll have 3 multiplied by 3 plus 1, which is 4. So therefore, what we've written this as, we've written it in the form of, once again, 1 more than a multiple of 3, because we notice we have our 3 here, and we're adding 1 on to the end. And we'll just write that down, which is also 1 more than a multiple of 3. So therefore, what we've done is we've worked through all three of these cases where we've now been able to prove that for any value that k takes, so for any natural number, it's always going to be a multiple of 3, or it's going to be one more than a multiple of 3. And we've shown that here by squaring everything and then factorizing it and bringing it into a simpler form. So now what we can do is we can just write a little concluding statement which relates back to the question. So therefore, we have shown that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. And therefore, we've completed this question. There was 4 marks on offer, so we achieve our first mark for attempting to square any 2 distinct cases of the 3 cases that we've identified here. So we attempt to square our second one just about here, so we'll give ourselves our first mark here, and we then receive our second mark for having the accurate results and making a valid comment for any 2 of the 3 cases we have. So we do this at this stage here, and we then make a comment and do it at the second stage here. So we'll therefore give ourselves our second mark at this stage here. And then we pick up our third mark for attempting to do the square, but for all 3 cases. So we'll just pop that third mark in here. And then we receive our fourth and final mark for accurately doing and commenting on all 3 cases and giving a minimal conclusion, which is where here we've related things back to the question. So we'll pop in our fourth and final mark at this end stage here. And therefore we've completed this question.